Now we'll see how to write the schematic for digital VLSI circuits. Okay, let us start with a very simple inverter where I'm supposed to have one NMOS and PMOS. So this is a microwind tool. So it is also called as, of course, in microwind we have this digital schematic 3. So let me just start with one NMOS. Other is PMOS transistor. Let me just place it here. So let me take this is my button, which is acting like an input. I can take this as my output waveform. Let me connect these things over here. This is the wire. Let me connect this to this. Then I can connect this to this here. So you can connect this. Okay. So inputs are connected. Let me connect this to this. Okay, this is that output point connected. Let me have this as the ground. Drag it here. Place it down here. This is VDD. Okay, I can put it down here. This is fine. Now, of course, we can double click on each one of them. Of course, you can get to know all these things. If you want to see all those pin numbers and symbols, you can make it all of them visible. So this is a PMOS gate, source and drain. You can do the same thing for this also. Let us start simulation of this one. You can see now this is 0. You can see the output is high here. If you make this as 1, that is low. And you can certainly see when I make it as low, the PMOS transistor is on. That's why there is a connection from this to the LED. That's why it is LED is glowing. You can see this is off because the VGS is 0 here, less than threshold voltage. If I make this on here, you can see NMOS is on, PMOS is off. So that's why the LED is off, because there is no charge for this, there is no voltage for this to glow. So this is a very simple thing. So let us do one. Of course, you can also see the waveforms here. Of course, you can see this is a waveform what you had. This is 0 input, output is 1 here. When the output is, sorry, when the input is 1, output is 0. This is exactly how you can able to visualize the waveforms also. So let us do one Nand gate. For that, okay, let me have, okay, you can delete this. I can delete this. Okay, let me delete it be there as it is. And let me have one more NMOS. Where is NMOS? This is NMOS. Let me drag it and place it here. Let me just make it. Let me minimize this. Okay. Let me put one NMOS. Let me put one PMOS. PMOS should be there in parallel with this. This is perfect. Let me make the wiring. Let me take ground down here. Okay, this is ground connected. Let me make the connections. This connection is made, and this I need to connect it to this point. It is also done. Let me connect this to this. It's also done. So let me name. Let me take one more button here. The button is this one. Okay, this is the second input. Okay, let me just place it here. Let me have the connector down from this to this. Then let me short this and this here. Okay, we can go up here. Okay, I think there is some problem. Let me just disconnect. Okay, I should not have this extra one. Okay, is this fine? So let me name this as, okay, how do I, okay, this is input 1, input 2. Okay, if both the inputs, if since it is NAND gate, when one of the input is 0, you have to get it as high. Let me run it. You can see both are 0, output is high. Let me make both of them 1. You can see when both are 1, both are turned on, both NMOS are turned on, you have the output voltage as 0. If you make any one of them as 0, because of this it is turned on, and even though this is off, so it doesn't matter. And of course you can see the diode, sorry, this diode, the LED is getting the charge from this VDD through this transistor. If you make this the other way, then it is coming through this. If you make both of them 1, it is this. If you make both of them 0, it is still on because both the P MOSFETs are on. So this way you can play with this. You can implement any circuit over here. Okay, that's it.